Alright, it's a tale of two welders. Or actually, three welders. That's my MIG that I've been just recently learning how to weld with. This Lincoln AC/DC Idealarc 250 came up on Craigslist, and I wanted to give it a shot because you know, it's AC/DC, and I figured it was worth the risk just for the scrap value, if nothing else. Great big old transformer. This thing weighs a ton, but you know, the cord has been cut, no leads came with it, and you know, I didn't think leads would be that big a deal, but I forget, you know, how expensive copper is nowadays. I priced out some leads for it, and it was going to be more than $200 just for the wire, and then you threw in another, you know, $50 to $100 for the connectors and the clamps and all that stuff. So, being cheap, I went looking for a welder that came with all that stuff on Craigslist, and came across this one. So, both of them, of course, need 220. And I didn't have that in my shop yet, so yesterday's project was to install 220, and then I tested that guy out, and it works, so I'm really kind of happy with that. That if nothing else, I've got an AC buzz box to go with my MIG, and not too much investment so far. So that'll give me plenty of learning right there, plenty of welding education to be had. So today, I've got around to cleaning this guy out, and I'm glad I went ahead and took all the covers off, because I found actual, no kidding, rat's nests or mice nests back in the I should have a light. Anyway, that's the fan back there, and inside of the housing was just full of rat's nest. So cross your fingers. I'm going to wire it up. I got a prefabbed range cord. This little guy here, 6 feet long, 50 amp, and that's what I'm going to wire it with. We'll try it. If it works, well, if it even sounds like it's working, like it's humming and the fan is going, what I'll have to do is try it out with just like some, you know, jumper cables or something, because I don't have the connectors this type. I have the Tweakos that plug in there. They make the adapters that go on here, but that's about a $50 investment just to buy those. I mean, nothing's cheap on these things. So I'll just, if it works, all right, I'll make the investment, swap the leads from this one over to this one, sell that one, be good to go. But I won't be too unhappy if I just have to stick with that guy and scrap this one. Okay, this is interesting. If I'm reading that correctly, this was born around 65 or 66, which makes it about as old as I am. That makes me want to save it. Interesting thing to point out here. Okay, see here, for low voltage, it gives you the instructions, and for high voltage, it gives the instructions. The low and high, it'll run 230 or 460. So for the low voltage configuration, which is what I need, you need to make sure that H3 is the one that's insulated, and H1 and H2 are connected to the switch. You can see where H1, H2, and H3 connect to the transformer there. So I was a little worried I was going to have to trace that out somehow and figure out which wires were which, but luckily they're marked. So you can read that. Can you read that? Focus! Focus! There we go, H3. So H3 is the one that's insulated. H1 and H2 are connected to the switch. So I'm good to go for low voltage. Now for wiring my cord, I'm going to replace this section here. Ground goes down here, and then my other two leads go right here. Alright, small difficulty I encountered was that this range cord won't fit through the orifice that was made for the round cable. I would have to cut a new hole bigger and use the bigger strain relief, they call it, for the range that came with this cord. I don't want to do that. So for testing purposes, I went ahead and wired it up, bypassing that. And if it turns out this puppy works, I will probably steal the cord from the other machine and do what I have to do to make this fit that one. Alright, moment of truth. We're plugged in. That's a good sign. See anything going snap, crackle, pop back there? Alright, I'm going to get out a voltmeter and start checking out some things. See how we're doing. Right now it's set on AC. So we'll try that out first, and then we'll check the DC, positive and negative. Check the AC here. Let's see what we got. Volts. Alright, DC positive. Volts. DC negative. Negative 80 volts. So far things seem to be pretty good. Okay. I'm reading right here that it says max OCV 72 volts. So I don't know what the C stands for, but I assume that means max output voltage 72 volts, which is, within the range of what I was reading. So, I think we got good news here.